space-time is an emergent realm, and there's something that it's emerging from, and that is the quantum realm that I see as a realm of possibilities or potentialities that are real, that are very real.
Keep watching to learn more.
Book 3 in the New Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.
Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. We'll be exploring the paradoxes of quantum physics today. With me is philosopher Dr. Ruth Kastner. She is a member of the Foundations of Physics group at the University of Maryland at College Park. She is also author of The Transactional Interpretation of Quantum Physics, The Reality of Possibility, as well as Understanding Our Unseen Reality, Solving Quantum Puzzles, and Adventures in Quantumland, Exploring Our Unseen Reality. Welcome, Ruth.
Thanks. It's great to be here.
It's a pleasure to have you with me here in Albuquerque. You use a wonderful metaphor for these paradoxes in quantum physics. The idea of a carpet that has a bump, a roll, a crease,
lump in it, a lump in the carpet.
A lump in the carpet. And no matter how you try to push the lump away, it shows up somewhere else.
Right. Yeah. I think I opened my book with this idea that quantum theory is like this carpet, this beautiful carpet that we've been given, and we really like it and it works well, but it just has this lump. It doesn't quite fit in the room, right? And those are the quantum puzzles or the quantum riddles.
And it seems as if the quantum physicists are trying to do just what you explained. Take a piece of furniture and cover up the lump so no one can see it.
Yeah, I mean, I might be a little harsh there, but it seems that though in various ways, the different interpretations are kind of different ways of trying to eliminate that lump.
Because my sense is that there are many different solutions, but every solution proposes a new paradox in order to explain the old paradox.
Right. I kind of see that as a bit of the shifting lump, and we smooth it out, and it looks nice in one spot, but then there's some other problem that pops up. And so what I'm trying to do is actually unfold the carpet. I'm saying, no, it's even bigger than you thought, but let's make our room bigger.
Yeah. That's a good way to get rid of lumps.
Right. Just get a bigger house.
I mean, because there's so many potential paradoxes.
Right.
There's the idea of particles going backwards through time, or faster than the speed of light, or the idea that things occur that have absolutely no cause whatsoever.
Right. It just challenges us in many ways. And I mean, my main argument here is that our living room, metaphorically, is the space-time realm. Our expectation that all physical things must take place in this 3 spatial and 1 temporal dimension, our space-time realm that we think everything happens in. And somehow the quantum theory carpet is just too big to fit in there. We have this non-locality that you mentioned, and these superpositions and these things that just don't make sense in our 3+1 space-time.
Well, of course, we have now one of the main theoretical movements in physics is string theory and the various other theories that are sort of variations of string theory, M theory, and so on, which postulate more than a three-dimensional or four-dimensional space-time matrix.
Right. Yes, those are theories that are trying to get a theory of quantum gravity, trying to unify all the forces. Mm-hmm. And yes, they are exploring those ideas. Mm-hmm. And so certainly there's other areas of physics where we're already kind of expanding our living room. We're mm-hmm. already looking to get a bigger set of concepts.
But talking about space, let's say 5 dimensions of space, or it used to be called the fourth dimension before people thought about 4D, 3 dimensions of space and 1 of time is 4D. Yeah. The fourth dimension was considered an invisible dimension of space in early science fiction stories,
right?
For example, but it's counterintuitive that there's more than 3 dimensions of space, and I don't think you're postulating that either, are you?
Well, I'm postulating not additional dimensions of space-time per se, but rather the idea that space-time is an emergent realm, mm-hmm. and there's something that it's emerging from, and that is the quantum realm that I see as a realm of possibilities or mm-hmm. potentialities that are real, that mm-hmm. are very real.
I've heard people refer to what they call quantum geometry.
Right, yeah. And so actually I'm not sure exactly what people might have in mind with that term, but certainly the structure of quantum theory has a kind of geometry to it that is not compatible with 3+1 space-time dimensions. It's much bigger than that.
Mm-hmm. So no matter how you slice the pie, you're going to end up with some result that is counterintuitive from our normal Newtonian macro perspective.
That's right. We're not going to be able to go back to that time when we thought that we had it all figured out and we had our 3 spatial and our 1 temporal dimension and a place for everything and everything in its place and everything was local and understand. The so-called local realism mm-hmm. is the term that people use for that view. And I don't think we can really go back to that. I know some people are trying to kind of hold on to it, mm-hmm. but I just think that those are ways of trying to nail down the carpet and having to deal with lumps popping up in other places.
Well, as a parapsychologist, of course, I've always been interested in this area because minimally speaking, we have a lot of empirical data in parapsychology, maybe not as rigorous as some would like, but still thousands of reports, and they're inconsistent with this local realism.
Sure. I mean, of course, physical science is an area that, properly speaking, doesn't really have anything to say about internal states of intuition and so on. And although it may be compatible with it, but I think when people from physical science try to extrapolate and say, well, based on my preferred physical theory, you shouldn't be talking about parapsychology, they're kind of going out way beyond where they should be going.
A physicist once wrote and said, if the parapsychologists hadn't already been reporting these things, we in the field of quantum physics would have predicted it.
Oh, really?
Yeah.
I see. So can you elaborate on that a little bit and what?
That the normal local realism, as you put it, mm-hmm. has one fundamental distinction that we make, and that is the difference between subjective and objective.
Right.
We all believe that, there's a world out there and a world in here, and they're different. And this physicist was saying that breaks down.
Well, I mean, I think that kind of approach came out of the measurement problem, the problem of saying, how are we going to account for the fact that the quantum theory gives us a bunch of different outcomes, or something in a superposition, mm-hmm. but we only experience one of those. And they they thought that perhaps consciousness had a role to play in that, and they used that as a way of explaining why you get one result. So that's perhaps one thing that may have led them to feel that consciousness had to be involved. And there still are a lot of physicists, I think, who do feel that quantum theory explicitly demands consciousness. And I have a slightly different view, in that I think we can explain measurement outcomes without invoking consciousness explicitly. Mm-hmm. But at the same time, I think that the structure of the theory points to aspects of reality that go beyond the local, realistic space-time world.
Well, there is this idea of a theory of everything in physics, which typically means integrating relativity or gravity with quantum physics. Mm-hmm. And yet, doesn't it seem to you that a theory of everything should also account for consciousness?
Well, when people use the term theory of everything, if they want to exclude studies of our experience, then clearly they're working in a traditional physical science paradigm, where their everything is the objective world. Mm-hmm. And that gets into very deep questions about what is science? What is the proper delineation of science? So it depends on your definition of science, as to whether you think physical science should explain inner experience. Mm-hmm. That depends on what you call physical, so it's a question of how one delineates
those. Of course, there are many other sciences besides physical science.
Right,
there's anthropology.
Of course, and So I think what the term theory of everything coming out of physical sciences is a little bit of a grandiose phrase, a little bit maybe overstated,
Well, there are a few people I know of who are attempting to integrate consciousness somehow into physical models.
Okay, right. And of course my model doesn't take a position on that, the model I've been exploring and the interpretation I've been exploring, but it's certainly evocative of the idea that we have real possibilities that are sub-empirical, by which I mean they are not part of what physicists usually think of as the objective world, the empirical world of the laboratory, but that the theory is kind of saying to us, hey, well, you may not want to consider this real, but this is the only way you can explain what's happening, and this is the only way you can interpret or predict what's going to happen. Mm-hmm. So the theory may be challenging us to expand our ontology and our metaphysical toolbox to the point where we're dealing with more subtle concepts that are sub-empirical. The minute you get into that area, you can argue that there's room for the mental, that there's room for the internal or intuitive modes of experience.
Well, it strikes me, and maybe I'm just naive, but it seems silly to have a science of physics that doesn't include the physicists themselves.
Yes, but they don't. Isn't that's the beauty of it? Or that's the interesting aspect of it, that, as you said, it presupposes a subject-object distinction. Yeah. And that the scientist is studying something, that the world is his laboratory, and he's going to find out about his world in a way that doesn't directly involve knowing himself. And then maybe an artificial division, and that may be that quantum theory is starting to point to the fact that we have to start looking at that division more carefully and see, how.
You're a philosopher, and philosophers, I think, all acknowledge the importance of Socrates as a foundational figure in philosophy, who said, know thyself. That's the whole point of philosophy, is it not? Of
course. Yeah. Yeah. And of course, physical science was originally called natural philosophy. Mm-hmm. So what they were doing was trying to gain knowledge of what they called the natural world. Now, maybe that was the initial impetus to break off, to take this sort of subject and object coin and to try to break it, so that when they were doing natural philosophy, it was the natural. The emphasis became on the natural, meaning the object in which I'm interested, and I will study it in a way that doesn't directly involve myself.
And I am under the impression that the church had a role in all of this, that there was something called the Council of Trent, I guess back in the 17th century or so, in which they divided things up, and the church said, okay, you scientists can deal with that which is measurable and objective, but everything else belongs to the domain of the church and religion.
That's a fascinating point.
Yeah.
That there were these kinds of cultural, political, historical reasons for this division, that it became almost a territorial thing.
Yeah.
And I can understand that makes a lot of sense, that the natural philosophers of the day would choose to go with the flow of that recommendation, because, well, you don't want to get on the wrong side of the religious authorities of the time, which we know they ended up doing anyway.
But the religious authorities have always postulated the idea of a supersensible realm. Yes. Which is precisely what the transactional interpretation, your interpretation of quantum physics postulates as well.
Well, it's a kind of, it doesn't really postulate it more, so much as say, this is a more natural interpretation of the quantities, but it is pointing to it. It's suggesting it. Okay. And it's saying that this is, I think, the most natural way and appropriate way to interpret the mathematical structure. And I talk about this in my latest book, Adventures in Quantumland, that this provides a way to reconcile these traditionally physical science and religious or spiritual ways of knowing, that they're actually perhaps pointing to the same reality.
I guess the word that I use, postulate, has a very specific meaing. It means
you're sort of helping yourself to it, right?
Yeah.
So, yeah, in a way. But I see it as an interpretive move that is, you can use the word, perhaps. I don't think of it that way, but it's probably fine to.
I'm just digging a little deeper here about the use of normally in logic, you start with a postulate, don't you?
Right. And in that sense, I'm not starting with it. I'm sort of following up and going, hey, this is what the model seems to suggest in that sense. So it's an interpretive move.
Yeah.
Yeah.
But one might say that interpretive move is at least parallel to what the church or all religions seem to do when they talk about this supersensible or spiritual realm. Well,
they have a history or a way of knowing that's based on revelatory modes of knowledge, which, of course, most scientists would say isn't a legitimate way of getting knowledge. And on the other hand, my model starts from a physical theory, and it says, okay, apart from thinking that we also need to understand a little bit differently how fields work, and then we have a better understanding of quantum theory and why we get measurement. But it also points to, I think, the theory itself, if we take the structure seriously, then say that it's really pointing and referring to something in reality, then the only logical move is to say whatever it's referring to is not in your manifest space-time phenomenal realm. And so, in a way, it's almost despite, as a more rigorous, hard-headed physicist, which is how I started into this field. Yes. It's almost dragging me kicking and screaming to this result. It's not like I went into this saying, oh, how can I make my model of quantum theory line up with religious thought. That was not a goal that I had.
I totally get that. But
it's interesting that it points
But
to
not
that.
all religious concepts developed out of revelation either. There's quite a bit of work suggesting that, religious traditions developed from empirical observations.
And rational thought. There are many logical arguments for the existence of God, for instance, and
there are those,
but
for sure.
Yeah, sure. Oh, sure. I mean, looking at the apparent design in the world around you, and looking for the ultimate designer and that kind of thing. So, yeah, it's very true. But of course, there are different ways of knowing, different approaches to gaining knowledge.
Well, we started by talking about paradoxes, paradoxes of physics in particular, but I suppose it's fair to say you can only have a paradox if you have a conceptual framework within which some observation appears paradoxical.
Right. It's not what you're expecting. You can't fit it into your previous understanding of how things should work.
So if you have a larger worldview that can accommodate these findings, then they're no longer paradoxical.
Right. And they can be understood in a natural way. I mean, for instance, perhaps one of the paradoxes is wave-particle duality. How can something be both a wave and a particle?
Right.
Well, in my approach, they are, as possibilities, they are waves. So that you have waves of possibility, but the particle-like quality enters in at the point where you have an actualized result, which is very rigorously accounted for in my model. Yeah. So that they both pertain, but at different levels of the process. There are different processes involved. So
well, when you refer to a wave of possibility, that's a very different kind of wave, I think, than one would perceive in the double slit experiment where you see interference patterns.
Right. But of course, what you actually see, if you're doing it with electrons or something, if you look at the screen, you see little dots. Oh. You see little dots. Wherever you got a result, there's a dot, and that's your particle-like aspect. But the fact that the distribution of the dots follows this wave-like interference pattern is evidence that you had, at the level of possibility, that you had wave-like behavior.
These are not physical waves at the level of possibility.
Well, they're not space-time waves.
Yes.
They're not actualized waves like water waves or something like that.
In other words, in your thinking about this, something can be physical without existing in space-time.
Exactly. Yes. Or at least it can be something that is capable of being described by what we call a physical theory, the theory of quantum mechanics. Yeah. So, I mean, I'm not saying, well, it's physical in the sense of being made of any particular kind of substance. Yeah. I'm simply saying it has a structure, it's real, and it's describable by this theory.
Well, it would seem to me, as a psychologist and parapsychologist, kind of self-evident, but maybe from the point of view of a rigorous theoretician, not at all self-evident, that if you have this vast realm outside of space-time or independent of space-time, where many, many physical things happen, the same thing should also, it's reasonable to assume, or it's self-evident to assume that would also be true of the mind.
Right. I mean, the funny thing about these possibilities is they're often called abstract, right? I mean, that was one reason people like Niels Bohr did not want to grant them physicality, because they are abstract in the sense you can't, they're not tangible. Yeah. You can't say, I'm putting my finger on this possibility. But by the same token, in the sense that they are subtle or abstract, that has a mental character to it. I mean, we think of the mind as dealing with ideas that are abstract. Yeah. So this is where these two concepts sort of come together, in the sense that these quantum possibilities could be said to have this mental character as well, in that they're abstract.
So in quantum physics, you have theoreticians who talk about many worlds, who talk about particles going backwards through time. They all have different models and different interpretations. They typically get rid of one paradox and introduce another to replace it with. And what you're suggesting is that all of that can be handled simply by acknowledging the physical or ontological reality of a realm that is not within space-time.
Right. I mean, I think that we resolve a lot of the puzzles by making that move and sort of expanding our living room so that the rug can fit in. We don't have any more lumps. Yeah. Right? We have a situation that is challenging to us because we thought that this is where our existence ended, or this is where the appropriate scientific domain of inquiry should be delineated at this boundary. But if we expand that boundary and expand our ontology, then I think we find the theory loses its lumps, and it makes a lot more sense. A lot more things are explained.
But then what remains to be explained is how something that has no existence within space or time can influence events that are within space and time?
Well, there's clearly an interrelationship between these two levels.
Yeah.
So this is a level in which, I mean, if you follow this idea, then things like hydrogen atoms, for instance, are real. They're physically real. Niels Bohr was right when he was developing his theory of the hydrogen atom that it really exists, and it's something we need to, as physicists, worry about. But according to, my suggestion here, it's not, the hydrogen atom is not actually contained within space-time, but it's a mediator of interactions in this broader realm of possibilities that can give rise to space-time events and transfers of real energy. So these are real, empirically measurable, actual things, photons, real photons that carry energy and momentum and angular momentum, so that they are clearly having an effect on the space-time realm in doing so. So that's what I mean by saying they're physically real. They are really doing stuff. They're not just in your mind. They are really doing stuff. We can create them in the lab. When I say in the laboratory, we can create them by way of procedures in the laboratory. But all of this is rooted in this sub-empirical realm of possibility.
I think at one point you told me, and maybe we can elaborate on this, make sure I understand it right, that a particle or an atom at rest, something with rest mass, is not within space-time.
Right. I mean, it's the fact that, for instance, take an electron.
Okay.
An electron is a fascinating little object that has rest mass, but in a sense, it's like trapped light. So it's actually in a kind of a little vortex it's spinning, but it's spinning in a dimension that is not in space and time. And that's, in a sense, it's really being trapped in an area that can't quite get into space and time. It's behind the scenes, but it interacts with the electromagnetic field, which is what gives rise to photons, and different electrons can interact with one another, and they're usually bound to something like an electron, and they can actually toss photons back and forth. But when that happens, that's something that's going on in space and time. So it's like there's a thing that you can do with yarn called a cat's cradle, where you can take yarn and put it around your fingers and then pull it apart. Like that. This is kind of a nice way to visualize what the electrons are doing. They're yarn that's not really in any kind of obvious structure, but they can give rise to strands of yarn that are then the part of the space-time. So they're acting behind the scenes, and they're very real, but they themselves are actually trapped, in a sense, in a domain that's not the space-time realm.
And all of this would be very consistent with the existing equations of quantum physics. Absolutely. The Dirac equation is what describes electrons, and it has very strange solutions. They are called spinors. They have four dimensions that have nothing to do with space and time. And they seem to be zipping backward and forward at the speed of light. But again, it's a very fast motion that's really this. Topologically, in a strict mathematical sense, they are really doing something that cannot be done in 3+1 dimensions. And of course, you have all these other qualities that seem really almost, very mysterious to me, like with quarks. You have a charm quark. I don't know what charm is in this sense, or an up quark and a down quark. And
yes, these are all sort of what are called internal degrees of freedom. Now, when people use that, they mean this is a way of moving that does not take place in space and time. So that's sort of the traditional language that's used around these objects that are doing things that you can't do in space and time, an internal degree of freedom. So that's, in my view, that's kind of one of the lumps that pops up that, that you put under the TV cabinet and just say, that's like, we won't talk about that. Call it an internal degree of freedom. Well, what does that mean?
Or use a word so that everybody's comfortable with the word without wondering what does it really mean. Right. Like, what is this charm?
Yes. And when you say internal degree of freedom, what's the inside, and what is it doing while it's doing that? But topologically, in a very strict mathematical sense, these are not space-time processes.
Well, there are so many paradoxes like this. I mean, almost every version of quantum physics has them. I understand, for example, in quantum field theory, particles are considered to have, they're point particles. They have no volume whatsoever.
Well, I think, that's one way of looking at it, but I think people who are really specializing in the foundations of quantum field theory, they generally agree, there's a consensus that the particle concept really doesn't work in quantum field theory. That it's very hard to really say, well, where is my particle? You can't really do it. It ends up being just very unwieldy to try to think that there are actual point particles in quantum field theory.
You just explained to me that in the double slit experiment, when you look carefully, you do see these points.
Well, that's at the actualized level, which again, traditional approaches can't really explain.
Yeah.
They can't explain why did I get a dot? They literally cannot explain that. All they have is a probability that I'll see a dot here or a dot here or a dot here, but there's no reason, they give no reason for why you actually got a dot anywhere. So,
and in your interpretation, the transactional or the relativistic transactional interpretation, how would you explain that?
Well, because you've got the role of absorbing systems as well as the role of emitting systems that are both necessary to have any transfer of energy. So, for instance, if you're doing a two-slit experiment, say with photons or something, then the systems in the screen are part of the dynamics. They are interacting with systems in the laser or whatever it is that's emitting these photons, and it's a mutual decision to have a photon go from the laser to a specific object in the screen. And a particular atom, say, can then absorb that photon, and then it changes its state. And that atom changes its state, and it actually triggers a cascade of all kinds of chemical reactions. And that's why you see the dot, because a transaction occurred and was actualized.
And that transaction is outside of space-time.
The process that leads up to it is outside of space-time. The one that then becomes actualized is the final space-time process. So that process really does establish a space-time actuality, or rather two actualities, the emission event, the absorption event, and then that photon that connects them.
Well, I'm very tempted to try and use that as an analogy for human behavior, but...
Well, you've got transactional analysis already, so... Maybe.
Perhaps I'm just being way too speculative, but it seems to me, you meet somebody and you get married, but maybe the interaction that leads to that connection, you and your husband, me and my wife, for example, took place outside of space-time.
Well, there's so many subtleties if you take quantum mechanics literally and say that maybe it does describe possibilities, then there are all these possibilities out there that are not, those possibilities are not like the flowers sitting here in this vase. They are not phenomenal things that you can put your finger on, but they're very real and they're really there, and you can act upon them or not, and they can influence you. Clearly, you can influence you, and you can think about them and go one way or the other.
So these flowers, they're beautiful. They came from my garden, but you seem to be suggesting that what we can see here or smell is just the tiniest portion of what they really are.
Absolutely. That's right. This goes back to the mysterious table in itself that Bertrand Russell wrote about in his Problems of Philosophy, that everyone will see a table, but strictly speaking, we can't really say, well, what is the real table that's underlying all these different perceptions that people have of the table. Well, in the same way, what are the real flowers that are giving rise? You're seeing a different view of the flowers. I'm seeing we're experiencing each experiencing our own flower phenomenon. And, the eternal puzzle of philosophy is, are there any flowers in themselves? Well, what I'm saying is quantum theory is actually providing us an answer to that at the quantum level, yes, there are flowers in themselves. They're not manifest, but they are very powerful. And together with the light sources, and the other systems that are in play are giving rise to these transactions. So we have a phenomenon that is flowers.
Well, Ruth Kastner, that's a very elegant explanation. I like it. And I want to thank you so much for coming to Albuquerque and being with me so that we can share these thoughts with our viewers. Thank you so much.
You're very welcome. I've really enjoyed it.
And thank you for being with us.
Book 3 in the new Thinking Aloud dialogue series is UFOs and UAP, Are We Really Alone? Now available on Amazon.
New Thinking Aloud is presented by the California Institute for Human Science, a fully accredited university offering distant learning graduate degrees that focus on mind, body, and spirit. The topics that we cover here. We are particularly excited to announce new degrees emphasizing parapsychology and the paranormal. Visit their website at cihs.edu. You can now download all 8 copies of the New Thinking Aloud magazine for free, or order beautiful printed copies. Go to newthinkingaloud.org.